Hello everyone, myself Varshita S from SVC. Today we will going to discuss about functionalities of Lex and Dax in systems of field. First we know about what is Lex and Dax. Lex and Dax are the tools commonly used in the development of compilers and interpreters for a programming language. They work together to automate the process of lexical analysis and syntax analysis. Lex is used for lexical analysis and Yak is used for syntax parsing. Output of lexical analysis are the tokens, and that tokens are the input for the syntax parsing, and the parsing tree is the output for the syntax parsing. This is the basic structure of the Lex program. First, there are three rules. First one is three sections: definition sections, rule sections, and user subroutine sections. And definition sections are start with delimiters. And the header files, and the delimiters will close, and the rule sections will start here, and it has two parts: patterns and action part, and here the subroutine sections will start. And now we will going to discuss about functions of Lex. Lex is a lexical analyzer generator. Its main function is to generate a scanner or lexer, which is responsible for breaking down the input sources code into a sequence of tokens. Lex uses the regular expression to define the patterns for matching these tokens, and it generates the C codes for lexers based on the provided specifications. The primary task of Lex, it includes the recognizing patterns in the input source code using the regular expressions, and it will assigning the tokens to recognize the patterns, and it will generate the code for lexers in a target language like C or C++. Next, there are YY variables are present in the Lex. The following YY variables are offered by Lex to aid the programmer in designing sophisticated lexical analyzers. These variables are accessible in the Lex program and are automatically declared by Lex in yylex.yy.c. First one is YYIn. It is a variable of type file and points to the input file. YYIn is defined by Lex automatically. If the program assigns any input file to YYIn in the auxiliary function sections, then the YYIn is set to point to that file. Next one is the YYText. YYText is a type of char, and it contains the lexemes currently found. Lexemes means it is a sequence of characters in the input streams that matches some patterns in the rule sections. That is, in fact, it is the first matching sequences in the input from the position pointed to by YY. Each invocations of the functions YYLex results in YYText carrying a pointer to the lexemes found in the input stream by YYLex. YYLex means it is a communication tool between the Lex and Yak programs. And the value of YYText will be overwritten after the next YYLex invocations. Next one is the YYLength. YYLength is a variable of the type int, and it stores the length of the lexemes. Next, some of the functions are there. First one is YYLex and YYWrap. YYLex is a function of return type int. Lex automatically defines YYLex in lex.yy.c, but does not call it. The programmer must call the YYLex in the auxiliary function sections of the Lex program. Lex generates the code for the definitions of YYLex according to the rules specified in the rule sections. That YYLex need not necessarily be invoked by the auxiliary functions of Lex program when used with Yak. Next one is the YYWrap. The Lex program declares the functions YYWrap of the return type int in the file lex.yy.c. And it does not provide any definition for YYWrap. YYLex makes to call the YYWrap when it is encountered to end of the input. If the YYWrap returns 0, it indicates false statements. And it returns 1, it indicates that that statement will true. Next, the YYLX assumes there is more input and it continues the scanning for from the location pointed to by YYN. And if YYWrap returns a non-zero, it indicates the true, and the YYLX terminates the scanning process and returns 0. Next, we will come on functions of YAC. YAC means it is a syntax parsing. So the wider.c files contains the functions of YY which is an implementation in C of a push-down automation. YYParse is responsible for parsing the given input file. The function YYLX is invoked by the YYParse to read the tokens from the input file. And this function is also automatically generated by the YAC in the y.tab.c file. Although YAC declares the YYLX in y.tab.c file, it does not generate the definition of for YYLX. Hence, the YYLX function's definition has to be supplied by the users. This is the program. This is the basic program for Lex and YAC to check whether the string is palindrome or not. This is the Lex program. This is the definition sections, which includes the header files and the rule sections containing the regular expressions A to Z, small a to Z and big A to Z. And if it is plus indicates one or more should be present in the string, and it returns if one or more text alphabets are present, it return YY text, and it will end the Lex program. And here the YAC program will start if yeah, the YAC program will start. This is also a definition sections which includes the header files. And here YYLX is called because to communicate the Lex and YAC program, we use the YYLX. And this is the rule sections. And if the given string is a palindrome, it will print it is a palindrome, or else it will print that the given string is not a palindrome. Thank you.